All right, picture this. You're sitting down for dinner, ready to dig into a delicious salad. Or maybe you've got a pizza calling your name.
Pizza.
Right. And you reach for that trusty bottle of ranch dressing, ready to drizzle it all over.
Of course, who doesn't love a little ranch?
But here's the thing. You tilt the bottle, give it a good shake, and nothing.
Oh yeah, been there.
It's like it suddenly turned into a solid brick, defying gravity and your dinner plans.
You know what makes you wonder in that moment, is ranch dressing even a liquid at all?
Exactly. And you know what? That seemingly simple question that we've all probably pondered at some point opens up a whole world of fascinating physics.
It really does.
So today we're diving deep into the science behind materials we encounter every single day, using ranch dressing as our unexpected but delicious guide.
I'm excited for this one.
Our mission to uncover the mysteries of what scientists call soft matter.
Soft matter, precisely, and you'll discover it's way more common than you might think.
I bet. But before we get into the nitty-gritty of soft matter, we need to lay the groundwork with the basics, right?
Absolutely. It's always good to start with a strong foundation.
So let's talk about the classic states of matter, the ones we all learned about back in school.
All right, let's see. Solid, liquid, gas, the trifecta.
Exactly like ice, water, and steam, the textbook examples. And just for fun, we can throw in plasma, too.
Oh yes, plasma, the often forgotten state, but so crucial. Think about the sun or those vibrant neon signs.
So what sets these states apart at a fundamental level?
Well, it all boils down to how their tiniest components, the molecules, interact with each other. These interactions, which happen at a scale we can't even see, dictate how the material behaves in the world we experience.
So like in a solid, the molecules are all packed in tightly, right?
Exactly. They're locked in a rigid structure. Think of an ice cube. Its molecules are held in specific positions, giving it that fixed shape.
Ah, okay, that makes sense. And then what about liquids?
In liquids, the molecules have a bit more freedom to move around. They can slide past each other, which is why water takes the shape of its container.
Right. It flows and conforms, so then gases, those molecules are just doing their own thing.
Pretty much, they're zipping around at high speeds with minimal interaction, bouncing off each other and the walls of their container.
Which is why they expand to fill whatever space they're in.
Precisely. And then there's plasma. It's like a supercharged gas where the atoms have been stripped of some of their electrons, creating a sea of charged particles.
Oh, wow. So it's like a high-energy state of matter.
Definitely less common in our everyday experience here on Earth, but incredibly important in the grand scheme of things.
All right, so we've got our classic states of matter, but let's get back to our ranch dressing conundrum.
Yes, that elusive condiment.
It doesn't quite fit neatly into any of those categories, does it?
Well, it's not quite a solid and not quite a liquid. It seems to straddle the line.
Sometimes it's thick and unmoving, almost like a solid, but then with a little shake, it miraculously transforms into a pourable liquid.
You've hit the nail on the head. It's all about this fascinating concept called elasticity. Even solids aren't completely rigid.
Oh, interesting. So like when you sit on a couch, it compresses but then bounces back when you get up?
Exactly. That's elasticity in action. Those molecular connections are behaving like tiny springs stretching and recoiling.
And on the liquid side, there's this thing called viscosity, right?
You got it. Viscosity is a measure of a liquid's resistance to flow, its internal friction as molecules try to move past each other.
So like honey versus water? Honey is much more viscous. It pours slowly and is harder to stir.
It is. Our source actually compares trying to swim in honey to trying to wade through thick mud.
Oh, yikes. That sounds like a recipe for disaster.
So we've got elasticity representing a solid's ability to bounce back and viscosity describing a liquid's resistance to flow. And now we're ready to tackle the mystery of ranch dressing.
I'm intrigued.
You see, it belongs to this fascinating category scientists call soft matter.
A fifth state of matter.
Precisely, soft matter is a bit of a rebel. It doesn't conform strictly to the traditional state.
So it's not a solid, not a liquid. It's
both. It exhibits properties of both viscous liquids and elastic solids. That's why it's called viscoelastic.
viscoelastic. Okay, that makes sense, I guess.
Yeah.
But what are some other examples of soft matter so I can wrap my head around this?
Oh, there are tons. You encounter them all the time. Think yogurt, cookie dough, shampoo, toothpaste, even silly putty, snot, slime, and frosting.
Wow, so soft matter is everywhere.
Absolutely. It's all around us, and understanding its properties is crucial in various fields, from designing better food textures to developing advanced materials.
Okay, so this viscoelastic nature, how does it actually play out in real life?
Well, think about shampoo. It pours like a liquid, but it also stretches a bit when you pull it apart, showing some solid-like behavior.
That's true. And cookie dough, it holds its shape, but if you press on it, it deforms permanently.
Exactly. These seemingly contradictory behaviors are the hallmark of soft matter.
This is blowing my mind. So what's going on at a microscopic level to make these materials act this way?
Well, a key factor is how their viscosity changes when you apply force or agitation. This brings us to shear thinning and shear thickening.
Shear thinning, so it becomes less viscous, more fluid when agitated.
You got it. And that's precisely what happens when you shake that stubborn bottle of ranch dressing.
It all makes sense now. The shaking forces the dressing to become more fluid and finally pour out.
Exactly. And the opposite can happen too with certain materials that's called shear thickening.
So they get more viscous when you agitate them.
Precisely. A classic example is oobleck, that mixture of cornstarch and water.
Oh, yeah. I remember playing with that as a kid. It's like a liquid, but if you punch it, it suddenly turns solid.
It's a fantastic demonstration of shear thickening in action.
So we know ranch dressing is soft matter, and the shaking is what makes it pourable. But what's the science behind that transformation?
The secret lies in a special ingredient, polymers, long chain-like molecules that get tangled up like a bowl of spaghetti.
Okay, I can visualize that. So these tangled polymers create a network that gives the ranch its structure.
Exactly when the ranch is at rest, these tangled polymers resist flow. But when you shake the bottle, you disrupt those entanglements, allowing the dressing to flow more easily.
So it's like you're physically untangling those spaghetti-like molecules.
That's a great way to think about it.
Okay, so is it safe to say that the defining feature of soft matter is its ability to change its behavior depending on the forces applied?
Absolutely. It's this dynamic interplay between its structure and the forces acting upon it.
All right, so what about ranch dressing specifically? Is there a particular polymer at play?
Our source points to xanthan gum, a natural polymer often used as a thickener and stabilizer in food products.
Xanthan gum, I see that on ingredient lists all the time.
It's everywhere, and those long xanthan gum molecules create the tangled network in ranch dressing.
So when it sits undisturbed, those molecules are all intertwined, giving it that thick consistency, but the shaking breaks those connections and it flows.
Exactly. It's all about those microscopic interactions.
Well, this has been a truly enlightening deep dive into the world of soft matter.
It's fascinating, isn't it?
So the takeaway here is that ranch dressing isn't just a simple condiment. It's a complex example of soft matter, exhibiting both liquid and solid-like behavior thanks to those amazing polymers.
And that struggle we all have with a stubborn bottle of ranch is a perfect illustration of shear thinning in action.
So the next time you encounter a substance that seems to defy easy categorization, think yogurt toothpaste. Even that dollop of, well, you know what I mean, consider whether it might be an example of soft matter.
It's a whole new way of looking at the world.
There's so much fascinating physics hidden in plain sight in the everyday materials we encounter.
It really makes you appreciate the complexity and wonder of the world around us.
Absolutely. Well, on that note, thanks for joining us on this deep dive into the surprising science of soft matter.
It's been a pleasure.
Until next time, keep exploring and stay curious.
Keep those minds churning.
And maybe give your ranch dressing a good shake before your next salad.
Definitely good advice.
All right, that's a wrap.